Okay. So this is the this mass of alloy is defined as 1 kilogram. So with respect to that, the copies have been distributed to all over the world. Okay. Now this is not the actual. This is not the definition for 1 kilogram, because now you can see they have placed inside two uh, chambers, two containers, right? That is to protect the mass changes from mass change. Because if suppose if it's open to the air, the oxygen will be there, it will react with oxygen and the oxides can form, so masses can change. Or if there's any degradation also, the mass could be changed. So therefore they have sealed inside two containers, because even if it's the mass is changed by 0.000001, then this is won't be a uh, good definition for the 1 kilogram. It is okay for 0.00001 change is okay for day to day measurements, but when it comes to scientific things, even changes in seventh or eighth, 10th decimal place also makes a big difference, right? So therefore, to avoid that, they have been placed like that. Okay, okay, and then SI unit system. So it's an international system that we all agree with. One set of unit system, right? So under the SI unit system, we discussed there are 7 base units and 2 supplementary units. Okay, so it is made up of 7 base units. So base units also known as basic units or fundamental units, and then we discuss supplementary units, derived units. Okay, and then we will be discussing multiples and submultiples. So derived units and multiples and submultiples we will be discussing today. Okay. Okay. Now let's say. Okay, Ikram, tell me all 7 base units with their SI unit. All the base units with their physical quantity. Now, for example, length is measured meter. So then there are other 6 more. Can you tell all 7? Okay. I can't hear you. Your audio is not working, I think.
Nine.
Can others hear Ikram speaking?
Hello.
I'm not getting your voice, not clear.
Hello.
Okay. I'm sorry, I didn't hear anything. I think maybe you are having a poor connection. Okay, so what are the 7 base units? We know length is meter, mass, kilogram, and time seconds. Yes, time seconds, and electric current ampere, temperature Kelvin, luminous intensity candela, and amount of substance is mole. Okay, so these 7 base units you should be able to say. Okay, and then there are 2 supplementary units. Okay, let me know what are those 2 supplementary units. Yes, radian and steradian. Radian is measure the solid angles. Okay, right. Okay. Okay, so here is something about atomic clock made of cesium atoms. So here 1 second is equals to 9,192,631 and 770 cycles of the standard cesium 133 transition. So this number will never change. So every second, this number of exactly this number of oscillations will occur because we have defined the second as this number of oscillations, right? Okay. The lone electron outside that means outermost electron. Okay, that's a lone electron outside the 54 electron symmetric core is at distance about 55,000 times the nuclear size. It has splitting of energy levels about 1 out of 100,000 the ionization energy and even 1,000 times smaller than the thermokinetic energy of the atom. But the exceptional precision of that tiny energy splitting allows to measure time with precision of 1 second in 1.4 million years. That means if we made atomic clock using cesium, then 1 second will error could happen in 1.4 million years. Therefore, atomic clocks are the most precious clocks. I think there are only 2 atomic clocks. One is in USA and the other one is uh, uh, research center in space. So these atomic clocks are used to the function of GPS because GPS also should have a very exact time measurements. Even if very millisecond of time error cause, the location shows different. Okay. So here is that this thing that definition of 1 kilogram that platinum iridium alloy. Okay. So it has been placed at Sèvres, France. So we'll go to that. So two supplementary is radian. It used to measure plane angle. So 1 radian is equal to 57.3 degrees. 1 radian is equal to 57.3 degrees. Guys, it's raining out here. Can I know whether you all can hear me clearly? Otherwise, I will bring out my mic and I can connect it. Please let me know. Yeah, no? Okay, okay. Okay, then I'll bring my mic and I'll connect it. Give me a second. Hi, mic testing 1, 2, 3. Is it better now? So 1 radian defined as the angle subtended by an arc length which is equal to its radius. So 1 radian is defined as uh, angle subtended by the center of the and subtended by the arc length, okay, which is equal to its radius, right? So 1 radius is the angle made at the center of the circle by an arc whose length is equal to its radius, okay. I hope you guys completed this, right? In last class I told you to complete this task, right? Raise your hand if you did. Well, I can't see anyone is raised. No one completed. Somehow did you complete? It's raining here. By the way, how about the voice now? Is it lagging or okay? Seriously? Okay, but anyways, you don't need the PDF to weave the PDF to complete this, right? Because I explained you, right? You know what is 90 degrees, and then you can find right each angle and calculate, right? So please, if you haven't completed, you can please complete. So steradian solid angles, we don't have much about steradian. Only thing you should know is the angle used to measure solid angle, and once steradian is defined as the angle subtended by the center of a sphere by an area of radius square. Okay. So the solid angle of a sphere subtended by a portion of the surface whose area is equal to the square of the sphere's radius. Okay. And this radian and steradian have no dimension. They have no dimension. Okay. So once we finish this part, we will starting the dimensions. So okay, so this radian and steradian, this plane angle and solid angle have no dimension. So plane angle and solid angle are dimensionless quantities. They have no dimension. Okay, and then derived units. So I think in the last class we talked from derived units. We just discussed derived units of area, volume, right? So derived units are measurements derived from 7 base units specified by the International System of. So derived units are units of measurements derived from the 7 base. So they have been derived from the base units. That's why we call it as derived units. Now, for example, area. So area, we can write length into breadth. Length into breadth. Okay, so here the physical quantity, physical quantity, and here unit, unit, and unit name. Area is, so here length is measured in meter and breadth is also measured in meters. Therefore, unit is meter into meter, meter squared. So we write square meter or meter squared. Meter squared. The supplementary units have units. Yes, no, obviously, right? So the units are radian and steradian, right? So radian is measured, the radian. Plane angles is measured in radian, right? So unit is radian. Unit name radian and the symbol rad. Yes, likewise, solid angle measured from steradian, and the unit is SR. So these are the units, rad and SR, right? Okay. Now, for example, let's say angle is measured in radian. Let's say radian pi over 2, 90 degrees, we write in pi over 2. So you can represent that angle pi over 2 rad, or you can write as simply pi over 2. It is not necessary to write the unit. Now, if you take length 7 meter, it is must to write the unit, meter or centimeter or whatever the unit you have to must write. But radian and steradian, it's not must. You can write either pi over 2 right, or you can keep it as pi over 2, right? Okay. So derived units, as I told you, we have area is meter square or square meter. Likewise, volume meter cube. the volume is length into breadth into height. Volume is length into breadth into height. So meter into meter into meter. So it will be meter cube, right? Or cubic meter. And then another derived unit I can think of density, where the mass divided by volume. Mass divided by volume. So kilogram divided by meter cube. Kg m minus 3, right? Density. So the symbol is kg m minus 3. The unit name kilogram per cubic meter, or you can say kilogram per meter cube, right? Kilogram per cubic meter density. And what else we have? So here it are speed meters per second. Name unit name is meters per second. Acceleration meter per second square. Pressure. Uh, so pressure is derived as kg m minus 1 per second square. Right. Now here the Pascal is not a derived unit. So this is the derived unit. Okay. So here Pascal is actually derived unit with special name. I think I had to remove this. No. So you want to write in your note the derived units, area. Here when you are completing the book, don't write this. So no need to write this so, because here the symbol is different and then the unit is different, right? So therefore don't write this so. Okay. So you should write this way. First quantity, the physical quantity. The first column has to be physical quantity and the derivation or how it's derived. So like let's say for area is length into breadth. So here you can write derivation. First you had to write the physical quantity. Okay, and then we can say or no need to or you can write derivation. And then unit name, don't write, right? And the unit and unit name, right? Now, for example, area. You can write length into breadth. So unit is here meter into meter. So meter squared, meter squared or square meter. And then volume. So you can write length into breadth into height. Okay. So meter into meter into meter, meter cube, meter cube, cubic meter. Okay. And then density. So density, mass divided by volume. So kilogram divided by meter cube. So then we get kg m minus c, kilogram per cubic meter, kilogram per cubic meter, right? So likewise, you had to write these speed, uh, energy, pressure, force, right? And what else we have? Frequency power, frequency power. So I write down the list. So you have to complete this later, this table. Speed, energy, pressure, force, frequency, power, yes, power, momentum, moment of force. Okay, so please include this in your chart, in your writing book, and if you know other quantities also, you may add them. Right. So this part you have to do later. Okay, then I'll clear this. And then deriving it with special names. Right? So, for example, frequency. Frequency is derived as 1 over seconds per seconds. So the symbol is hertz. So the SI unit symbol is hertz. So it has a special name, right? The Newton. These are the special names: hertz, Newton, Pascal, Joule, Watt. So the most of the almost every special names are given to honor a scientist. Right? So hertz is the frequency, force Newton, pressure or stress Pascal, energy Joule, power Watt, electric charge Coulomb, right? So you can complete this table also later, right? In your notebook, that write down. So you can write down the definition of deriving units. For example, what is the definition of Newton? 1 Newton is the force required to accelerate 1 kilogram mass to an acceleration of 1 meter per second square. So that is the definition of force. Likewise, you can take some of the main units: frequency, force, energy, right? Pressure, the Pascal, for example, Pascal. So this unit, you can take out 5, 6 units, and you have to write the definition of that. You can find out. You can search in Google, okay, or you can use some books, okay. Okay, and then multiples and submultiples. So we call in general prefixes. So these are prefixes, right? So these are multiples and submultiples. Both together we can call this as prefix. I don't know, in your previous grade in English class you may have learned prefix and suffix. I don't remember. So prefix means which is comes before the word, no? So therefore here you can see all these are comes before the unit. So therefore we call this as prefixes. Now for example, centimeter. So centi is the submultiple and centimeter comes before the unit. So it's called, these are called prefixes. Okay. Okay. So here we'll start with deca. Deca means 10 to the power 1. So 1 decameter, 1 DAM. 1 decameter is equals to 10 meters, right? And 1 hectometer, 1 HM, 1 hectometer is equals to 100 meter because it's 10 to the power 2. And kilometer, that's you already know, right? 1 kilometer is 1000 meters. 1 kilometer is 1000 meter. Okay. And mega is 10 to the power 6, giga 10 to the power 9, tera 10 to the power 12, right? And beta 10 to the power 15, exa 10 to the power 18, zeta 10 to the power 21, iota 10 to the power 24. But you guys at least should know up to beta. Okay. At least must. Okay. If I ask you what is 1 petabyte, you have to say it is 10 to the power 15 bytes. If I ask you what is 1 terajoule, then you have to say it is 10 to the power 12 joules, right? So you know nowadays the mobile uh, cap the data storage comes in right, gigabytes. But hard drives we can find 1 TB, 2 TB hard drives, right? So so if you take 1 TB, it can store 1000 times the GB, right? Okay. So these are multiples. So when you are writing this in your notebook, you start writing from deca to from top to bottom to top, right? That means first you write this 10 to the power 1 is deca symbol DA, and then the next row you write 10 to the power 2 hecto. So in that way, it will be easy for you to study, right? Like a mind map. Right? If you write the note like this from here to here, it will be difficult to memorize. But rather, if you write in this way, so 10 to the power 1 is deca, 10 to the power 2 hecto, 10 to the power 3 kilo, 10 to the power 6 mega, 10 to the power 9 giga, 10 to the power 12 tera, like that you can easily study. So when you're writing, completing your note, so please make sure you write from here to here. Did you all understand? Okay. No need to write now. I will. You can complete these things later. Okay. So we can't allocate time to write these in the. We want to make uh, our classes more effective, and that means we had to do a lot of things. And as I told you in the last class, I plan to finish the syllabus soon. So once we finish earlier, then we can practice a lot of questions, right? In that way, it will help you to get good grades in your exams. Okay, right? And then submultiples, 10 to the power minus 1 is deci. So for example, if I say 1 decimeter, that means 1 decimeter, 1 dm is equals to a meter divided by 10. So 10 to the power minus 1, no, 10 to the power minus 1, if you write in the plus index, 1 over 10. So 1 meter, you have to divide by 10. So 1 over 10 meters, right? And centis, we know meter divided by 100. And milli is 1 meter divided by 1000. Micro is divided by 10 to the power 6. That means 1 meter you divide by million, get micro, right? Okay, and then 10 to the power minus 9 is nano. And 10 to the power minus 12 is pico. Okay, By the way, you should have an idea about what are these. Like normal estimation, you should be able to say like one deci is something like 10 centimeter, no? So it's the length of a pencil. So 1 centimeter is the thickness of hand. 1 millimeter is thickness of hair. Something like you had to, you should have some idea the range of these values. Okay. And suppose if I ask you 1 kilometer, so 1 kilometer, you should have idea like from here to a distance. So 100 meter is a football ground or 100-meter race, right? So those things you should be able to, it should come to your head. Okay. Okay. So now, for example, 1 nanometer is something like in the range of molecules, right? Nanometer, nanotechnology, you use these uh, molecules and what, yeah, to synthesize nanomaterials. What is the average size of atom? For example, hydrogen atom. Hydrogen atom is the radius of hydrogen atom is, for example, 0.5 angstroms. So angston is equals to 10 to the power minus 10 meter. This one you study in chemistry class, like bond lengths and all. So size of hydrogen atom, therefore 1 angstrom. This radius, no, so diameter. So that means 10 to the power minus 10. So if you write in nano, it will be 10 into 10 to the power. So sorry. So 10 to the power minus 10, you can write as 10 to the power minus 1 into 10 to the power minus 9 meter. So 10 to the power minus 1.1. So 10 to the power minus 9 is nano. So in the range of 0.1 nanometers is the size of a hydrogen atom, right? And pico 10 to the power minus 12. And 10 to the power minus 15 is femtometer. Femtometer is actually size of nucleus. Size of nucleus. To take the nucleus, its size is approximately in femtometer, in the range of femtometers, right? Because if you take a football as the nucleus, the size of the atom would be the size of the football ground. If you take the nucleus as the, if you compare, if you take the nucleus as the size of football, then the atom will be the size of uh, football ground, even more than that actually. Okay. Because you know an atom is mostly made of empty space, right? Only small region is nucleus, and then uh, point particles like electrons will orbiting around the atom, right? Now, for example, if you ask a biologist what a human is made of, they will say 70% water. If you ask chemist, they will say the percentage I'm not sure, some 60 or 40%, I'm not sure, made of carbon and hydrogen. Okay. And if you ask a physicist what a human is made of, then he will say 99.9% of empty space. So our body is made of 99.9% space, right? Because we are made of atoms. An atom is 99% empty space. Therefore, we are made of, humans are made of 99% of empty space. Now, for example, you know Empire State Building. Empire State Building, it could be something 110 stories in America, USA. If you squeeze its mass, like there's 99% space there. No? So without the space, if you squeeze only the mass, you can take the size of a grain of rice. I'm not exaggerating. This is actually true. Okay, this is a fact, fact, physics. Okay, if you take the Empire State Building now, even if you take one story apartment, maybe your home, how much of mass would be there? Like all the bricks, all everything, right? So then you see that mass will be like kilograms and tons, right? The total mass of your home, it could be in 2000, 3000 or more than that kilograms, right? If you weight all the bricks and the bars and the ceiling, roof, everything, will come a huge mass, right? So now imagine 110 stories building, right? You can squeeze in and get it to your hand, squeeze, so the size will be the grain of sand, right? Okay. By the way, don't worry, these things are not syllabus, just to give some uh, additional knowledge about physics. This is really interesting subject. No? Okay, so you can complete this later. Okay, so here at least femtometer you should be able to know. You should be able to know at least up to femtometer. So here the submultiples in you should write in this order. Okay, you can write in this order. But this multiples you have to write in this order. Then only it will be easy to study. Okay. And do you know uh, who are the scientists who got Nobel Prize last year in physics? But this year in physics is Nobel Prize given to two scientists who work in the under foundations of AI, the network, um, because the neural network, it's like the algorithms. There is something called neural network. So that's underlying principles are made of like 25 to 30 years ago by these two scientists. Now AI has become most advantageous and very useful to the community. So they have decided to give the physics uh, Nobel Prize for those two scientists. And by the way, nowadays there is an counter argument is going on. Uh, there should be a specified Nobel Prize for computer science. So why are giving this? There is no, and some other scientists are arguing the Nobel Committee haven't give a uh, Nobel Prize in physics. Some are saying like that. But according to my point of view, even if you take computer science, the underlying things are physics actually. Everything is physics. So there is nothing wrong. They have given the physics Nobel Prize for those two computer science. Okay, the computer science also a branch of physics actually. Okay. So by the way, the original question that I asked you, do you know who are the scientists who got the Nobel Prize last year for physics? Okay, I got the name here, but I'm not sure with the name. But I know those two scientists got the Nobel Prize for detecting a light pulse in the range of attoseconds. So they got the Nobel Prize because they have able to detect a light pulse in the range of attoseconds. So nowadays the computers I think works the speed is and all like in picoseconds. That means the time taken nano or pico. I think in that range, the computer operation range. So the computer can do operations like 10 to power 7 or 8 within a seconds. That's why computers are fast. They can, if you take supercomputers, they are now, for example, let's say there is a problem in maths, like for example, finding the uh, prime number, right? For example, finding the prime number, like maybe finding the largest prime number. So that is a huge problem, right? You know, the in computer science, you study like hacking, ethical hacking, and encryption, decryption. So That encryption means, now for example, you can take this WhatsApp. So in WhatsApp, it becomes, these conversations are encrypted, right? From one to one. That means if I'm sending a message to one person, no one can, no third party can leave. Only me and that person will communicate, right? That message is encrypted. So only that person is able to read, right? So my encrypted message. So when I'm sending a message, will be sending as encrypted message. So that person, he will only have the decryption key. So he will automatically, he will read the key. So if another third party want to read that message, he want to decrypt. So there could be any, there might be uh, com- codings, right? So these coding he want to hack. So most of the codings are encrypted using prime numbers. So they have used a large prime numbers. You want to find the factors of prime numbers. That's a huge question problem. So if you take a normal computer, it takes like years of years. But supercomputers, it takes like, it even that also take 10 years, right? So that kind of complexity is there. No, even more than that, actually, you can see Three Brown, One Blue. His YouTube channel, he has posted encryption using prime numbers. So I think it takes like even supercomputers takes 100 years, like 30 years, 40 years, right? Okay. So now that means what I'm telling is the computer's speed is has a limitation, right? So it has some limitation. Even though it's very fast, it has some limitations, right? So these scientists, they have figured out light bulbs in the range of attoseconds. You can see attoseconds is 10 to the power minus 18, 10 to the power minus 18. So if they can detect uh, light bulbs in that range, then they can do any sort of operations in that time range. Then the speed of future computers speed will be very maximum, very fast, right? So I can give you a small glimpse of idea how this 10 to power minus 18 is very small, right? Now you can calculate total number of seconds from the moment of Big Bang. Now when I started this class at 8:30, now also I don't know, like thousands of seconds as we have passed, right? 1 hour includes 3,600 seconds, right? Now we have almost 9:30, more than 3,600 is spent. Every second, a second is running, right? So if I ask you how many seconds are there from the moment of Big Bang, so from a moment, from that moment to this moment, how many seconds will be there? You can just give a rough number. You can text in the chat box. Guys, only the first two class I'll be do extra talkings, and then once we, now probably from next week I will start the session, means I continually do the sessions, right? Because we had to do a lot of, since now you are new novice to this A level physics, so I'm going with slow phase, and little by little the pace will be increased. Okay, tell me how many seconds would be there. Just give a rough idea, like some 10 to the power 5, like 10 to the power 10, or 10 to the power 20, 10 to the power 50, or maybe you can, if your guessing is right, I don't know, no, maybe you can guess Google. Google means 10 to the power 100. How many seconds would be there from the moment of Big Bang to now, exact this moment? You don't have to say exact question because that second is running over the time. You can say just rough estimate value. I need an response from each of you, right? Please drop a message. You can't write 10 to the power, so you can say 1 and followed by, maybe you can put 10 zeros, or how you can write the powers in text format. You can put the 10 and this 10 and this, and you can say 5, 10 to the 5. Oh my God, this somehow is talking Greek septillion. Septillion, if I'm correct, it has to be 70 million. What is septillion actually? It's okay, you all can Google it, the answer. Or before that, first I need your insight, your thought about how many seconds would be there. Okay, let's do the calculation here. Okay. So, what is the age of the universe? At least tell this, okay? What is the age of the universe? Oh, हमारे general knowledge अभी. You have to have these knowledges as general knowledge. Okay. If you are a science student, you must know it's necessary. It's like a normal thing. Okay. The age of universe is something like 13.5 or 6 or 7 billion years. Let's say for 13 billion years. Okay. 13 billion years. So 13 billion years, I write BY. Okay, so we'll calculate how many seconds are there. So in 1 day, 3600 seconds will be there. Sorry, in 1 hour. That should multiply by 24. You get number of seconds in 1 day. This one you had to multiply by 365. Then you get number of seconds in 1 year. And then you have to multiply this by 13 billion. Billion is 10 to the power 9, right? So this number of seconds approximate, right? So let's calculate this. On how to escape. So if you multiply this, we get 3600 to 24 into 365 into 13 into 10 to the power 9. Okay, so 10 to the power 9 I'll keep aside and I will get this number of, okay. It's, so what we get, so it's actually 4 multiplied by 1, 2, 3, 4, 5, 6, 7, 8. 4 multiplied by 8 into another 10 to the power 9 is there. So what do you get? 4 into 9 and 18 is, so 9 and 8 is 10 to the power 17. Understood? So this 4 into 10 to the power 17 is smaller than 10 to the power 18. Okay, and smaller than 10 to the power 8. That means now I'm going to, that means the number of attoseconds within 1 second, the number of attoseconds within 1 second is greater than the total seconds spent in the universe. I mean, the of the age of the universe. Do you understand? එක තත්පරයක තුල තියෙන ඇටෝ සෙකන්ඩ්ස් ගාන මේ විශ්වයේ ආරම්භයේ ඉඳලා මේ මොහොත දක්වා තියෙන තත්පර ගාන වලට වඩා වැඩි. Did you understand? The number of attoseconds within a second is greater than greater than number of seconds passed in the throughout the age of the universe. Okay, did you understand this? Come on, guys, please respond yes or no. How about Atika, did you understand?
Yes.
And Ikram? Okay. So 1 attoseconds is 10 to the power minus 18. That means you take 1 second and divide by 10 to the power 18. That means in 1 second, 10 to the power 18 attoseconds are there. So you can see this number, the total seconds spent throughout from the very moment of Big Bang to now is smaller than number of seconds within us, number of attoseconds within a second, right? So therefore you can, I hope you can understand the significance of this 1 attoseconds. So then imagine if we can construct a computer in the where it make operations in the range of attoseconds, then the computer speed and all will be very fast. If you want to download a movie, let's say 10 movies, it will take less than micromilliseconds, even small than. Okay. Okay. Then the technology will improve very fast. Okay. Okay. So yeah. So those are for multiples and submultiples. You can complete that later. And then today we'll move on to the lesson dimensions. Okay. So you all can write down the topic dimension. Okay, dimensions. So there are 7 dimensions for every base quantities. Okay, so write down there are 7 dimensions there are 7 dimensions for there are 7 dimensions for corresponding to 7 basic physical quantities corresponding to 7 basic physical quantities. Okay. So physical quantity and its dimension. So starting from time, time, time. The dimension of time is capital T. Length. Dimension of length is capital L. And then mass. Okay, now you guess correct. Yes, the dimension of mass is capital M. And we have temperature. Temperature theta. And electric current. Electric current is capital I. And luminous intensity is capital J. And amount of substance capital N. Okay, write down. And out of these, for us, which is important is these three, the dimensions used in mechanics. If they ask you a question means they will ask you from these. If you finish writing, raise your hand. ఎవరైనా hand raise. Okay, good. Okay, good. So here, the notation of dimension is we write like this. So time dimension. So this box bracket, we use box bracket to denote dimension. So dimension of time is capital T. Dimension of length is right equals length is capital L. Dimension of mass is equals to capital L. So write down small point. Dimension is denoted in square brackets, and you can write dimensions are denoted in square brackets. Dimensions are denoted in square brackets, and then you can write this time. So you read this as dimension of time equals to capital T. Dimension of length equals capital L. Dimension of mass equals capital. Okay. And so the topic is dimensions of derived units. Dimensions of derived units. Okay. So for example, let's say we want to get the dimension of area. So what we write? Area dimensions. So dimension of area is, we can write area is, we know, length into breadth. Okay. And here I put a, spread note. You can write in your as side note. So note. So dimension of first point, dimension of AB is, we can write as dimension of A times dimension of B. And then dimension of A divided by B is, we can write dimension of A divided by dimension of B. And then dimension of A to the power 2, I will say A squared dimensions is equals to dimension of A squared. And then dimension of A to the power n. So that is, we can write A dimension of A power n. Okay. And then last point, if K is a dimensionless quantity, if K is a dimensionless quantity, dimensionless, that means no dimensions, dimensionless. Dimensionless is actually one word, dimensionless quantity, then uh, then K dimension equals to 1. If there is a quantity has no dimension, so its dimension value is 1. Example, for example, 2. 2 is just a number, so dimension is of pi rad. So pi rad, so red has no dimensions, so it is again 1. Okay, so quickly note down this. Okay, are you done writing? I think I finished writing.
Yes, sir.
Okay, if you're still writing means you can take a screenshot. So here, let's say we want to, if you're still writing, you can take a screenshot. Okay, so here, let's say we want to find the dimension of area. So dimension of area is length into breadth. So we can write dimension of length into dimension of breadth. So dimension of length, dimension of length is L, and breadth is also a length. So it also has a dimension of L. Therefore, dimension of area is L square, right? Then you can find the dimension of volume. Please quickly find. And then also density, dimension of density. So don't write now. I know you know the answer for the volume is L cube, but this is starting as a note, so you want to complete the note. So write in this method. Okay. Length into breadth into height. So length into breadth into height. So you will have L in L times L times L. So L cube. So write down the steps. Okay. And density is mass divided by volume. So here you can straight away you get. So here you take length into breadth into height. So density you can take the dimension as mass divided by volume. So here straight away you can put the dimension of volume. So mass divided by volume. So then this one we can write dimension of mass divided by dimension of volume. So dimension of mass is capital M, volume is L cube. Since now you have found here, so L into L into L, so L cube. So you can straight away write. Therefore, ML minus P, the dimension for density. You can find the dimension of speed acceleration. if the dimension of speed is, we know distance divided by time. So dimension of distance divided by time. So L over T, LT minus 1. And acceleration is equals to speed, velocity divided by time. So here speed and the velocity have the same dimension. And acceleration is velocity divided by time. So it's actually the change in velocity over time. Change in velocity over time. So the velocity of dimension of velocity LT minus 1. Therefore, the change in velocity also have the same dimension. So you will get LT minus 1 divided by T. So LT minus 2. You can get an idea about the dimension from the units also. So here you see ms minus 1. So ms minus 2. Okay. Acceleration and then momentum. Momentum, find the dimension, and force, energy, work done, and pressure. Pressure, torque, the moment of force. Find, find the dimension of these quantities. If you finish, you can snap your answer and send it to me through the chat box. Not to Rima's Visa, you have to send it to the Knowledge Institute. So then I can view it on my device. On my laptop. So find the dimension of these quantities, and each of you has to send your work. So Somehow I still writing. Oh, but, can you send it your working? Send your working to the chat box. You can capture it and send it and attach in the chat box. Please send to the other part, like the knowledge. Mathika is still writing. And Ikram. Finish it soon. Somehow can you send your work? You can capture it, take a picture, and when you come to the chat box, you can see attachment is there, the round plus. So when you click, you can attach the photo there. So in the chat box, you can attach files. See the options, you can find the emoji. Send it to the knowledge institute. Send it to the knowledge institute. Is disable switch settings. Okay. So here momentum is mass into velocity, right? So we can write as is equals to mass times velocity. So here put the equal sign. Okay, so m into LT minus 1. So it's equals ml t minus 1. Okay, and then force is mass times acceleration. You have to put the equal sign. And this is equals to this. It's equals to this. It's correct. ml t minus 2. So the dimension of force is ml t minus 2. Now what is the energy? Energy is now suppose we can do with the work done first. So work done is force into displacement. No? Force into displacement. force into displacement. Okay, so then we can write force is, now we have found ml p minus 2 into displacement is L. So therefore ml squared p minus 2, ml squared p minus 2. Therefore the force dimension, sorry, work done dimension is ml squared p minus 2. Now what is energy? Well, energy is the work done. No, energy is the ability to work. Now if you do a work, that energy is transferred and stored as a, so that work done is stored as energy. Now for example, lift, if I do work to lift this, that work done is transferred as gravitational potential energy. Right? So the energy is the ability to do work. So energy has the same dimension of work done. So therefore, it also has the dimension of ml squared p minus 2. Okay. Is that clear? I will erase these things. Okay. So you can write work done is force into displacement, not distance. In your O level, you have studied, but actually, the work done is equals to force into displacement. Now this is we start is actually uh, a vector dot product. We will study about that. Um, so there are two types of vector multiplications: vector cross product and dot product. In dot product, we multiply two vectors and then we get a scalar. Right? So therefore, here force into displacement, not the distance. Okay. So momentum dimension, if we got correct, ml t minus 1. As into force is ml squared, sorry, ml t minus 2. ml t minus 2. Energy ml squared t minus 2. Work done ml squared t minus 2. Work done has and energy are same thing. Therefore, they have same dimensions. So torque, we know force into a perpendicular distance. So torque is the torque is equals to force times perpendicular distance to the line of action of the force from the pivot point. So it's a distance here. So here let's write down like this: force into the perpendicular distance. So here also it's better if you write perpendicular. Okay. So therefore, force ml t minus 2 into perpendicular distance L. So the torque has same dimension of energy. The torque has same dimension of energy and work done. And pressure is equals to force over area, dimension of force divided by dimension of area. So ml e minus 2 divided by L square m L minus 1 e minus 2. So pressure is ml minus 1 T minus 2. Okay, and then What else we have? Angular momentum, frequency. Let's write down those. Frequency, periodic time, and we have angular momentum, angular momentum, angular velocity. Planck constant, Planck constant. What else we have? Find these dimensions. So frequency, we know 1 over the periodic time, 1 over periodic time, or you write period. So 1 over capital T, therefore T minus 1. Periodic time is the time capital T is specified. Angular momentum. So angular momentum is given by L equals the moment of linear momentum, radius into linear momentum. So angular momentum equals to angular momentum is equals to radius into linear momentum. So radius is a length, capital L, linear momentum ml t minus 1. So therefore angular momentum we have m l square t minus 1. Angular momentum in the arcs. So angular momentum is ml squared t minus 1. And angular velocity. The angular velocity is given by v equals r omega. So omega equals v over r. So angular velocity is given by velocity divided by radius. So velocity is Lt minus 1 divided by radius length L. So L and L cancel, we get T minus 1. So you can see the angular velocity, the dimension is T minus 1. That is the same dimension as the frequency. Therefore, angular velocity is also known as angular frequency. In some textbooks, they refer angular velocity with the word angular frequency, right? So angular velocity is also known as angular frequency. because you can see it has the same dimension as frequency. Okay, and what is Planck constant? We know E equals hf, where n E is the photon energy, h is Planck constant, f is frequency. Therefore, h equals E over f. So the Planck constant is equals to energy over frequency. Energy divided by frequency. So energy dimension is ml squared t minus 2. That should divide by t minus 1. Okay. So then if you simplify, you get ml squared t minus 1. So you can see the Planck constant and angular momentum have same dimensions, ml squared t minus 1. In 1 year past paper, they have asked which of the following has the same dimension of Planck constant. So the answer should be, they have given the options: energy, angular momentum, uh, inertia, like that. They have the options. So the correct answer is angular momentum. So which of the following quantity has the same dimension of Planck constant? It is angular momentum. Okay. Did you able to write everything? So I'll clean this. Okay. So uh, now we have derived the dimension of many derived unit quantities, right? Here you should be able to say the dimensions. Like for example, let's say, what if I ask you? What if I ask you what is the next number after 5? Without thinking, you will say it's 6, right? If I ask you what is the next number after 10, without thinking, you will say 11, right? That's obvious, right? So because you have been used up many over times, right? So if I ask you what is the next letter after B, you will say C without thinking. Likewise, if I ask you what is the dimension of force, you have to say ml square t minus 2 without thinking. Okay. If I ask you what is the dimension of, force is ml t minus 2. If I ask you what is the dimension of energy, ml square t minus 2. What is the dimension of pressure, ml minus 1 t minus 2. So you have to say that without thinking. So you have to practice these over and over and over, right? So you can write a summary, right? So you can take summary and write now starting from force. Force dimension is, so you can write everything in one page. At ml t minus 2, mass times acceleration, energy. So dimension of energy is ml square t minus 2, right? So that is the work done as well. Work done. For heat, heat also same. Heat also energy, right? So you write down this, okay? Energy, and then momentum. So dimension of momentum, ml t minus 1, and pressure, ml minus 1 t minus 2. and then you can write force, energy, momentum, pressure, what else, torque. Here you can write torque also has the same dimension of work done, right? So torque also you can. So then energy, work done, heat, torque have same dimensions. So if you write this way, it will be easy for you to study as a mind map. Okay? Pressure and angular momentum. So angular momentum has dimension m L square t minus 1, and that is the dimension of Planck constant. Planck's constant. So you can write this way. So if you suppose in your when you are going through some other lessons, if you find out there is quantity that has the dimension of pressure, so you can put that here. So stress has the dimension of pressure because stress is force over area that you study in the mechanical properties of matter in elasticity unit. You study stress. So stress has the dimension of pressure. Yeah. So if you found when you are going through the lessons, if you found another quantities there, you can add that also, right? Angular momentum. What else we discussed? Uh, Angular velocity. T minus 1. So that has the dimension of frequency. Okay. So likewise, you can these things when I ask you, right, what is the dimension of pressure, you should able to say without thinking ml minus 1 t minus 1. Okay, right. Okay, so good. Now we can study the applications of dimensions. Okay. So let's write down the topic, applications of dimensions. So topic, applications of dimension. Okay, so the first one is we can use dimension analysis to see whether an equation is correct or true, right? So that is one application. So verification of an equation formula, verification of an equation, verification of an equation involved consist of physical quantities. Consists of physical quantities. So we will be discussing three applications under this. So the first one is verification of an equation of physical quantities. Verification of equation of consists of physical quantities, or you can say the verification of a relationship between physical quantities, right? So you can write like that: verification of a relationship between physical quantities. So one relationship we can consider as example f equals ma, right? So we want to find out whether this equation is correct. So what we can do is we can check whether both sides have the same dimensions. So then here f has dimension of what? Dimension of force is ml t minus 2, and then we can consider the dimension of right hand side ma. So that is dimension of m times dimension of a. So the mass capital M into acceleration lt minus 2, therefore ml t minus 2. So therefore we can state that therefore dimension of f is equals to dimension of ma. Therefore we can write, so the the equation is or relationship is dimensionally correct. Dimensionally correct. So if there's an equation relating with physical quantities, what you can do is you can consider the both side dimensions. If they are equal, then that equation is dimensionally true. Did you understand? Okay. Now, okay. So I'll give you some side notes. So these are important regarding this. Okay. So okay, first write this down. Will you? Have you finished writing? not, you can take a screenshot. So you can take a note, right? So now let's say there is equation where A equals B plus C, right? This one. Or you can consider A equals B minus C. In either case, so dimension of A must equals to dimension of B must equals to dimension of C, right? Now this is for example, let's say B is 2 liter of coconut oil. 2 liter of coconut oil, can you add 1 kilometer there? No. If it's 2 liter of coconut oil, this is also like in liters, like another 1 liter of milk, right? So then this one will give total volume of 3 liters, right? So the dimension of A, B, and C are same, should be same. They must be same. Okay? And the next one, A equals to BC plus D. Then dimension of A must equals to dimension of BC must equals to dimension of D, right? That means suppose if in question, if you want to find the dimension of D, what you can do? So dimension of A equals to dimension of B into C. Now you can write B into C. Therefore, dimension of B is equals to dimension of A divided by dimension of C. Understood? And the next point, if A equals B plus D over C over D, okay? D plus C over, or dimension of A must equals to dimension of B must equals to dimension of C divided by D, right? If there's anything you don't understand, please ask, okay? And the next one, if I say A equals to B times 1 minus CD, 1 minus C for example. So in this one, okay, the dimension of A is equals, it should be equals to dimension of B, okay? And so here to consider this bracket, the one has no dimensions. So therefore the C also has to be dimensionless. So dimension of C should equals to, we know if C is a dimensionless quantity, its dimension has to be 1. We put a note in the previous slide, right? K is a dimensional quantity, the dimension K is equals to 1. So here the C should be dimensionless, therefore its dimension should be equals to 1. Okay, and the next point, I write A equals uh, A equals B times 1 plus CD. So here dimension of A must be equals to dimension of B, and then dimension of CD equals to 1. That means the dimension of C should be equals to 1 over dimension of D. Okay. In the next one, A equals to B plus C D square. Then here dimension of A should equals to dimension of B should equals to dimension of CD square. And the next one, uh, let's say, okay, A equals to B to the power C. A equals B to the power C. Then here dimension of A must equals to dimension of B to the power C. Okay, and dimension of C should equals to what? And dimension of C must be equals to what? Tell me. I need an answer. You can drop a message in the chat box. Okay, I got an answer from Atika, and it seems very. So the dimension of C must be equals to 1 because it's a power, right? The power we can't take, like for example, let's say B is 2 meters. 2 meter to the power, let's say time something like 5 seconds. 2 meter to the power 5 seconds. No, the power is always dimensionless. It should not have any dimensions. So C has to be a dimensionless quantity. So its value is 1. Okay. And the next one, if I write A equals to uh, B to the power C over D, then dimension of A must be equals to dimension of B to the power C over D. Okay. And the C divided by D. Again, same argument has to be dimensionless. Therefore, 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 the dimension of C must equal to dimension of D. If these two have the same dimension only, they will divide and give. For example, C is 5 meters, then D also has to be in the units of meters. If C is in unit of time, then D also has to be unit of time. If C is unit of kilogram, then D is also in the unit of kilogram. Okay. So quickly write down this, and there are more. I had to write. I gave. There's no space, so first finish write down this, and then I'll give the more. Okay, if you're still writing, you can take a screenshot. 3, 2, 1, done. So the next one, next point, let's say A equals A naught times e to the power minus B over C. So here the dimension of A should be equals to dimension of A naught, and E is a number. It's a number. It's something like 2 point. So 2 point some 7. I'm not sure. It's a so here some number to the power minus B over C. So then here the dimension of B should be equals to dimension of C. Then only this B over C will be dimensionless. Okay. Right. Else I need to discuss. Okay. So one last, let's say, so let's say A equals to A naught times uh, e to the power, say ax plus b. So therefore here ax plus dimension of A should equals to dimension of A naught. Okay, and here we can write here dimension of E into ax plus b is equals to 1. It has to be dimensions. Likewise here also e to the power minus b over c. It is a dimension 1. Okay, and then also ax plus b has to be a dimensionless 1. Therefore, the ax dimension of ax equals to dimension of b equals to 1. Okay, I think that's all enough. So you can write this down. Okay, so 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 write down this question. Show that the following formula is dimensionally correct or true. Dimensionally, or you can write. So the formula is C equals ut plus half at squared. So I'll give what are these variables. So S is the displacement, and U initial velocity, and A acceleration, and T time. Okay. So You can do this as homework. So it's only for today. I will be wind up the class earlier. Now it's 11. I'll finish the class now. Right. So next week onwards, we will have the class from 8:30 to until 12 o'clock. Today I have some commitments, so I'll wind up the session soon. So you can send the do this question. What you have to do is you have to show this the dimension of S is equals to dimension of ut equals to dimension of half a square. All these terms have the same dimension. So do that and send it to the to me through the WhatsApp, so I can. Okay. Okay. If you have any questions regarding today's class, you can ask now. Okay. Then I guess everything is fine, right? So yeah, study well. Have a